So mock 4, question number 5.
What? Which one? Can you
Uh,
just speak loudly because I'm not able to hear you properly.
Hello. Now am I audible, sir?
Yeah.
So mock 4, question number
Mock 4.
question number 5. So qualifier portal you are opening, na? April qualifier portal.
It's okay. I think it's both are fine, right?
Okay, then fine.
Okay, I'll just check. Maybe you have got the solutions for these questions, right?
No,
For
sir.
mock test.
No. So that only I was asking from morning actually.
Okay, fine. Okay. What I'll do is open the qualifier portal then.
Okay. Sir, and if possible, and if the solutions are available by tonight, if you uploaded, it would be better, sir. If we go through it, then we'll bit better.
Yeah, okay, we'll try. But I tomorrow we'll be having exam, right? How many
Yeah, sir.
questions again?
Just
Then
if
you
we
will.
see once, no, if we glance at it once, na, then we get a bit idea, sir.
Okay,
For that reason.
okay. I'll just connect with them and see what I can do for you. Okay. Just a minute. I'll just check. So today my voice is something. It's properly audible, right?
Yeah.
Because I'm having somewhat cold, so my voice is not that good today.
Okay.
Okay. So mock test for your saying, huh?
Yes.
Number 4.
Five.
This 5.
Yes.
Okay. So what's out here?
So, how to start it, sir? Because when we do NC7 and NC8, so I'm not able to proceed.
Actually, yeah, I understand. But this is actually it's no, it's not that. It's logical question actually. So it's not like you'll get some correct answer or something like that. You can solve it and you will get correct. For example, let's say you have this, right? So you have to do some trial and error here. So NC7 plus NC8 minus NC4 and minus NC5. So you know the properties, right? So anything like NC8 and NC4. So actually this is 0. It's given that, right? So you can see
Yeah.
7 plus 5 and 8 and 4. So if you can see NC8 and NC4 values are same, and then NC7 and NC5
NC5
values are
values are
equals,
same.
right?
Yes.
So what can be the value of n then? It should be 12, the 8 plus 4. Then only it is possible, right? 12C8 uh,
Yeah.
12C8 is equals to 12C4, and 12C7 is equals to 12C5.
Yeah.
When these conditions are satisfied, then you will get these things cancelled, right? So you'll get 0 here.
Okay.
That's it.
I was solving it actually. Okay. So,
Yeah, it's okay.
next question.
Uh,
Sixth question.
so this is some standard question, right? You have this kind of so many questions of these kinds are there. Can you tell
Yeah,
me
sir.
how
I
you solve
got
this question?
answer. I got
Yeah,
answer as
yeah.
100 and
Okay, I will do check
1152.
answer so that it will be okay.
I
Okay,
got answer as 1152.
okay. So okay, can you tell me
So
how you solve the question?
yeah, sir. We have 4 girls and 4 boys, and we are
Hmm.
conditioned that we should not 2 girls should not sit together. So we will first
Hmm.
arrange 4 girls by 4 factorial.
You should have to actually arrange 4 boys first. Okay. 1, 2,
Oh no,
3,
means
4. Yeah.
I'm saying that and now in between, so,
Spaces are
if we
there only.
arrange first 4 girls and then
Hmm.
to satisfy the condition, we will put boys in between them, no?
Okay,
So
okay, that is also possible. Okay, that
that
is
was
also
I'm
fine.
saying.
Okay, tell me.
So
Here
this
you arrange the 4 girls.
girls, yes.
How
So this
many
would be
spaces
4
are there in
factorial,
between?
no? Three
One,
three spaces.
yeah, this will be 4 factorial. Yeah.
Yeah,
How many spaces are there?
3 spaces.
No, here also you have to count, right?
First, if we consider only the 3 places and then we multiply by 2 factorial, then also it is okay, no?
Why you have to consider only 3 places here? You can arrange the boys here also, right?
Okay, so fine.
Then
We'll do that.
that's why you are getting a wrong answer, because
Because
then
one of
you
the
are reducing
questions
the
in
number of ways.
so one question in previous mock, sir had said that we had 10 Indians, 5 Americans, and
Hmm.
5 Australians. And in
Hmm.
that question, we
Hmm.
did in this way. We first arranged.
But yeah, correct.
Huh.
But in that case, right, the 5 Australians and 5 Americans are different, right? The whatever five are there, they are different. Here, boys are same,
And sir,
right?
in that, I
If
think
you
they had
have
said
10
that
American,
they had said that there are only 20 seats because
Yeah.
so here sir, in that case it was given limited seats. Here the seats are not limited, right? You can take any number.
Okay.
no, still anything. It's okay, right?
Suppose if here
That
they
is
have given
also
there are
if you
8
have
seats.
20 seats only.
Huh.
In 20, if you have that kind of like more than 20 seats also, that it doesn't matter, right? If total people are 20 there, right? I don't know how
Yes.
many. Let's say there are 10 Americans, 5 Australians, and 5 something what Indians, let's say.
10
So in
Indians
that case
and
also, if you
others
have more
4.
than 20, it doesn't matter.
Yeah.
Now it's okay.
Okay.
The nationality doesn't matter. Let's say
Huh.
what I'm saying is, here there also, if you have more than 20 seats, but the condition to be satisfied is these people should not be sitting together, right? Same nationality people should not be sitting together, right? There also you have to first arrange 10 people first, right? Then you have only these spaces in between. If you more than the 20 seats also there, if you arrange these guys here, it doesn't it won't okay, in that case
Sir, the
no,
choosing
still
doesn't come.
also.
Choosing we do 5C2, 5C4 actually for 4 girls. But in that case, the choosing doesn't come because there are only 10 seats remaining after placing the Indians. And we have 10 people.
Let's say you have 10 Americans there, right? Let's say I'm having 10 Americans. So if I'll arrange 10 Americans here, right? These places, let's say. And if I have more than these seats also, but I'm not going to arrange 5 Australians here, right? Because if I arrange here, then these are again sitting together only, right?
Yeah. But yes, sir. So we are limited to
What
20
I'm
seats
saying
only.
is, yeah, if they are again only. Don't think like these chairs are there. I'm sitting. One is empty seats. So what is mentioned there? 20 seats are there because to not to confuse that students that okay, this person is there and this is the empty seat. Some might think like that, right?
Yeah.
Like one American is sitting there, one empty seat is there. Again another. So you can say that these are not sitting together. But to avoid that confusion, we said that there are only 20 seats available. Now, how can you arrange these people? And in this case, you have to arrange let's say 4 girls you are arranged here, and if they are not sitting together, so in that case also you can say like this, right? If more than 5 seats are there, still one can say I'm arranging 5 boys here, sorry, 4 boys here and 4 girls there. If 8 are there. Okay. I need to mention 8 seats also here, right? To avoid the confusion of that empty seats. Correct?
So
Okay.
can
If
you
more than 8 seats are there, then
so can you explain the concept of these kind of problems once more? I mean, did not understand completely. And whenever some
see,
question comes like this, we get confused a bit. So maybe you can just explain the concept
so
independent of any question.
Okay,
So here only,
I
if you
can tell
complete
you,
that
but the
question,
thing,
it would be better, sir. We will get an idea. So five
let's
places
see.
were left now. So we will arrange four boys in 5P4 ways, right, sir?
Yeah, correct. So 5p4, or you can say, yeah, that is the same thing again, right? 5 factorial ways. See, anything is permutation, so you can say 5 factorial ways directly, it won't harm, right? It will give you the same answers. Okay,
Yeah,
I'll
yeah,
tell you.
yeah.
So let's say you have arranged girls here, correct? So this place is also, so these two girls should not be sitting together. That means something should be there in between two girls, right? So while tackling this kind of problem, you have to think that if some entity is not sitting together, that means something should be there in between these two entities, right? Same entities. So here if you have boy here, boy here, boy here, and boy here, that means these two girls are not together. Or the another arrangement could be, let's say these are the girls. Then I can have boy here, like this. Correct. This is also possible.
Your screen seems to be
So
lagging a little bit.
and is it?
Yeah, now
Maybe
all of
signal.
them have come.
Yeah,
Okay. So I should write slowly, I guess.
yes.
So yeah, network issues are there. So maybe, yeah. So what I was saying this. Okay, I'll go slow. So I'm having girl here, girl here, girl here, girl here. So another possible arrangement is boy here, boy here, boy here, and boy here. Again, the thing is, uh, these two kind of arrangements are possible, right? Here, only these two kinds of arrangements. Either
Yes,
girl
sir.
first from here, and then you will have boy at the end, or boy at first and you will have girl at the end. But again, these all girls are different, right? So let's say this is G1, G2, G3, and G4. These are B1, B2, B3, and B4. So here also B1, B2, B3, and B4, G1, G2, G3, and G4. Now you can arrange these girls, right? So now G1, G2, G3, G4. Instead of that, you can have G2, G1, G3, G4, and again B1, B2, B3, 4, like that. Again same. So these kind of permutations are possible there. So how to solve these problems is, first of all, uh, pick four seats, right? Pick four seats and arrange four girls. So that can be possible in 4p4 ways, right? Or 4 factorial ways, you can say, right? So both are same, right? You are choosing four seats, and now you are arranging four girls on those seats. So how many combinations are there? 4p4. Sorry, permutations are there, 4p4, or you can say it's 4 factorial, right? Now how many spaces left, like how in how many places you can arrange those boys so that these girls should not be together? So there are total places, right? So here also, like before that girl one, then in between this, so you will be having like this. So 1, 2, 3, and 4, or you can have the places like this. So total of 5 places are there. In that 5 places, you have to choose 4 places, and then you have to arrange 4 boys. So these are like this 5c4 into 4 factorial, which is nothing but 5p4, right? Or 5 factorial, or not. I think is it right? 5p4 and 5 factorial. Yeah, 5 factorial same.
Yes.
So yeah, so you can do that like this. So your arrangements will be like this, right? Total arrangements. So what is the answer then?
Yes.
uh,
Now it is coming 28.
yeah, 2880, correct. It's 2880.
Sir, had this been a circular arrangement, what changes would we do this to this question? I mean, to this solution? Had it been that the seating is circular and
So
no
in
two girls should
yeah,
be
yeah,
together? I mean,
yeah,
it
in
gets
that case,
confusing then.
okay, in that case, the thing is, let's say these are the 4 seats, correct? So first of all, uh, in those 4 seats, how many girls, like what are the type of So how many permutations are there to sit those 4 girls first?
N minus 1.
So
So it will be
N minus 1
3.
yeah,
3
factorial.
it will be
factorial.
3 factorial.
Yeah.
Now how many places are there in between 2 girls? 1, 2, 3 and 4, right?
Yeah.
4.
So again, only 4
3
places are there
factorial.
now. Now you don't have five places, so it will be having 4 factorial. No, here don't see. If you first of all, if you choose this 4, right, if you fix these things, then it will come as linear permutation. It won't be then a circular. So you should not do again 3 factorial there, because see, logically you
Selection
can
of
see
boys, it
that.
will become linear.
Huh? What happened?
After selecting girls, at the
Huh.
time of selecting boys, uh, permutation will be linear. That you are saying, right?
Yeah. So you can think of like this, right? So how many places are there here? 1, 2, 3 and 4. 4 places are there. You have to fill these 4 places by 4 boys, and then you have to arrange them. So it will be 4 factorial. So this the answer should be 3 factorial into 4 factorial. Okay.
And U seating is always
It's okay,
considered
right?
as linear, na sir? If it is a U
Not new
seating.
sitting, I can say. Uh, in case, I think you sitting. So yes, yeah, it can be considered as linear, because again, uh, in this case, right, there is no loop completed. So if you have this kind of, if you have different people there, it will be considered as different, right? So you can consider it as linear only.
So we can follow
I
the
think
same
this kind of
approach.
questions are there
Yeah.
yesterday also, right?
Yeah.
I
U
think
seating is there in N term mock actually.
no, but I think yesterday's session I got the feedback that yesterday's session also these questions were there. Well, it's okay. You can ask it, but we can go for other questions also. I can say that. So your times
Question
won't
number
get affected.
9 of
Yeah.
this.
Sir, I have a question from an
Yeah.
activity
You in you
question.
setting, it should be linear. Huh? Okay. We can go one by one. Okay, it's fine. My voice is coming
Sir,
okay, right? Because I'm
Yeah,
feeling
sir.
that
yes,
my
Yeah,
it's
voice
coming
your
is
fine,
voice
sir.
is
kind of breaking.
Sir, activity question 9.6, question number 2.
so don't
Okay,
close
we are
this
not
folder,
again
okay, sir?
coming here.
So we will
So no,
come there, sir.
this. Yeah, otherwise you can go along with this, because if I go there, it will close automatically. This is portal, right? So
Yeah.
okay,
So
anyone is having any questions from here, they can ask and we can
Sir,
go
activity
one by one.
question 9.6.
question number 9 in this
Uh,
mock.
Sir, are you able to hear my voice?
yes.
Yes, you are audible.
Hello, sir.
Yes.
So
Okay,
question
I
number
have
9.
opened the activity next. Okay.
Question 2, sir.
Question number 9 is there is no 9 question, right, in activity
Sir,
9.6.
question number 2.
Oh, 2. Okay. Tell me how you have solved this question, or
Sir,
how you approach these questions.
yeah, I first try to find the probability of drawing a red card from the pack of the cards. So what would be the
Okay.
probability of getting a 0 card, 1, 2, and 3 red cards?
Hmm.
Is what I
Okay,
first try
so
to
your
find.
random variable is, yes, correct. So what is your random variable?
0,
It's
1, 2, and 3.
yeah. So your no, but first of all, define the random variable. What is the random variable? Number of red
Probability
cards,
of number of red cards, right?
not probability. Not
Yeah, number of
you're
red cards.
defining. Yeah, number of red cards. When you draw the 3 cards from a deck, like that,
Yes,
right?
sir. Yes, not probability, just drawing
Then
the red cards.
you can
Correct.
have, correct. So then you can have 0 red card, 1 red card, 2 red card, or 3 red card.
Three red
Correct.
cards,
That
right?
is the
Right.
possible number of values taken by the random variable. Yeah.
Right,
Now
sir.
then, now
Okay.
what you do
Then
then?
finding the probability of getting a 0 red card, then finding the
Hmm.
probability of 1 red card, 2 and 3 red
Hmm.
cards. So probability of getting a 0 red card is getting all the 3 as red cards. Sorry, all the 3 getting as black cards.
Okay, anything. Yeah, correct. Yeah, black cards. Yes. So, what is the probability then to get 0
Um,
red cards?
0 red cards is 26C1 into
Hmm?
26C1 into 26C1
Okay.
divided
Okay, I
by
am writing whatever you're saying.
52
Okay.
divided by 52C1 into 52C1 into 52C1
Just a minute. I think you with replacement, right? Yeah. Okay.
with replacement, right, sir? With replacement.
So it should be 52, 52, 52. Yeah. So it will be
Yeah, yeah.
1 by 8.
1 by 8, correct.
Correct? Yes. Huh, huh.
Then
Then
for
what is the probability that
1,
you're, yeah. So this is a PMF, right? This is your PMF. You are finding the PMF
this
of
is
X.
PMF, correct, right? PMF of X, right, right.
Huh. What is the probability? Yeah, 1.
Then again for 1, I was doing the same way. It would be because pulling out one red card
Hmm.
is 26C1 upon 52C1.
So have you considered this one? Okay, have you considered this 3? Because there are 3
3.
places, I mean, 3
Hmm.
positions are there, right? Either it will, your red card will come at first position, like at whenever if you have drawn 3, right? So let's say you have drawn one card first, that will be red. Then
Hmm.
other 2 cards are black, or
Yes,
it can be the
the
second
second
red card
position.
or the third. So you can have the 3C1 into this, or you can think of like this. Uh, so
So,
okay,
but
26,
we are
26 into
considering,
26,
but we are
or
considering it over here only, no? 26C1 is the probability of the
no,
first.
no, no, no. See, so this is what is this 26C1 here? It is, let's say, out of the 26 red cards, first is the red card. These are the black cards, right?
These are the black cards,
26C1.
right, sir? Right, right,
Yeah.
right.
Then so either you can choose
Got it.
any
Okay.
one of the
3.
position into you do like this, or you can
Hmm.
add 3 times. So maybe you did
Okay.
the mistake here. So it's
Yes,
P
I
by
did it
2.
because 1 by
Yeah.
8 was for everything.
Yeah. Then it will be 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Then you
And
can
then
find the
perhaps, yeah, and
CDF.
then we can just add it CDF. Okay,
Yeah.
sir. Yeah,
Yeah.
fine, sir. Thank you.
Yeah.
Thank you.
Okay.
Sir,
Okay.
can you solve week 12,
Yeah.
activity 2, question number 9?
Okay. Sorry. Week 12. Activity which one? 12 point. Hello.
So week
Vibhav?
12,
Huh.
activity 2, question number 9.
Okay. 12.2. Question.
Hello, sir. Am I audible?
Yeah. Yeah. Yes. Yes. I'm opening it. You can see here, right? So, yeah. Uh, which one? Question number 9. Huh? Suppose that random variable x is uniformly distributed between 0 and 10. If find probability of x plus 10 by x is greater than or equal to 7. Okay. Uh, okay. Can you tell me how you solve this one? So your random variable is uniformly distributed between 0 to 10, and you have to find probability that x plus 10 by x is greater than or equal to 7. Can you just tell me how can you approach or how you have approached your problem, this problem?
Sir, the thing which is given,
What do you understood?
so
What?
if we suppose x plus 10 upon x is a, so it is given that probability of a greater than equal to 7. We can write it as 1 minus probability of a less than equal to 7. So it will be 7 only because it is a uniform distributed. So it will be
No.
6.
6 what? Probability.
Yes, sir. The thing which is given.
But the thing is, probability cannot be going more than 1, right? Your value of probability should be always between 0 and 1, right?
Yes, sir. I mean 6 divided by 10. It will
So
be
how
0.6.
0.6 you're saying?
Yeah.
You're saying, but whenever you're finding any probability, so let's say
It's maybe point
let's say
3 maybe.
I'm asking you. Okay, you Okay, okay, no, okay, don't get confused now. So, okay, I will tell you. So, let's say my random variable is going from 0 to 10 here, and this is uniform. So, what will be the graph
Yes.
of that uniform random variable? It should be like this, right?
It will be straight line.
And value,
Yeah.
it's 1 by 10, correct?
Yes, sir.
So you are saying that probability that x plus 10 by x is greater than or equal to 7 is, you are directly considering. So, what is here? It is x, right? And it is probability of x, right?
Yes, sir.
So you are finding the probability that x is greater than 7 here.
Hmm.
If you are saying 0.3, then that means you are finding the probability that x is greater than 7, right?
Yes, sir. 0.3.
This is the value, right? You are finding out now. Means
Hmm.
whatever you said is,
Yes, sir.
and is this the same? Is this both expressions are same?
Yes, sir. It's same. Means if we consider x
How?
plus n upon x as a variable
Hmm.
a, so if we consider, then this will be same. If x is a something variable, if we suppose it.
But okay, let's say x plus 10x is you have considered as a, so you are finding a probability that a is greater than or equal to 7. This is a new
Yes, sir.
random variable, right?
Yes, sir. Yes, sir. This is a new random
So
variable.
do you have that distribution known? No, right?
No, sir.
But what is the distribution of a? Then how can you find that? How can you say that a is greater than or equal to 7 is 0.3?
Because we have learned, na, sir. If p of a greater than equal to 7, we can write it p of 1 minus p of a less than equal to 7. And if it is a uniformly distributed, so it will be equal to x only, whatever it is given.
Is it? I don't know. I mean, like, whatever you think. Anyone is like anyone from our class? Do you agree with him with this, or you understand what he said?
So can you please repeat?
Okay, Vaibhav, can you tell everyone that what or Vaibhav? Not I don't know your name.
Yes, sir.
Sorry.
Yes, sir.
Yeah, Vaibhav. Yeah. Can you just
Yes,
tell
sir.
everyone what you said?
So we have learned that probability of if is our probability of a greater than equal to 7, we can write it 1 minus probability of a less than equal to 7. And if it is a uniformly distributed function, so it will be equal to x only, means whatever is given for probability a greater than equal to 7, whatever the probability is given.
No, I don't think so. That is true.
No. Yeah.
Yeah,
Less
okay,
than or
okay.
equal to, the
Huh.
equal to will not come, right?
Huh.
So okay,
Huh.
okay. First of all, this is something. This is right. This is a new random variable. First of all.
X plus
Yes,
10 upon x is x square plus 10 upon x. That he is
Yeah. So
not
what?
considering.
How you have to find out is you have to just you have to just take down to the some known random variable value. So here it should be x square plus 10x. See, this x will go here. You have to multiply all like throughout this equation
huh,
by
sir.
x.
Yes, yes,
So
yes.
It's a
you will
quadratic
get
equation, solve it and get it, is it?
yes. So now your expression will be like this. Then
Yes, sir.
x
The
square
x will
plus
be 5 and 2 if we solve it.
so if you solve this equation, okay, let's say not greater than, you just make like this for now
Huh.
to solve
So
the
x will
equation,
be
right?
5 and 2.
So it will be
I think so.
5 and 2, right?
Yeah.
5 and 2. So one minute, just a minute. I think
X is greater than 5 and x is greater than 2. It means x is greater than 2.
No, minus 5 and 2, right?
yes, something, yeah. So one minute. Some mistake is
So
No,
the
5 and 2,
probability
sir,
will
not
be
minus 5.
so
5
the,
and 2.
so the probability will be x square minus 7x plus 10 is greater than equal to 0.
equal to 0, yeah.
X minus
So
5
we should not, yeah,
greater than 0. So x is greater than 5.
like this.
Yeah.
Yeah, this equality inequality you should have to consider.
Yeah, then
So
x
in
is
that,
equal to
X minus 5 greater than 0.
So that is x minus, yeah, x minus 5 into x minus 2 is greater than equal to 0. This comes out to be this.
Yes.
Just
X minus 5 into x minus 2 greater than 0.
no, that is okay. This thing, this thing is
So
fine.
either
But
x minus 5 is greater than 0 or x minus 2 is greater than 0 because product of two numbers is 0.
So can we break it
So,
into cases? Like, say,
so at
for
the end, it will be x greater than equal to 5 only if we will consider
Or
this both
this.
cases.
And
no,
out
but
of
both
that,
of them can be negative also, right? So if both of them are negative, so it will
how
the
come they are
probability will still
negative?
be. So if
No,
you
no,
put
both of them can't be
so
negative, no.
so
Both
if
of
you
them
take
can't
any
be
value
then.
between 0 and 2, so if you just put in 1 here, so the expression will ideally
Why
be
we
greater
should
than
put
0
1? Why we should put
because
1?
the uniform distribution is defined over 0 to 10.
No, first
So
we should get the condition for x and then
1
we
minute,
think
1 minute.
about substituting the
Okay.
values.
Okay, just a minute. Okay. So until this is fine, right? This
Yes, sir, yes, sir.
inequality
Yeah.
is fine, right? Here.
Yes.
This is okay.
Yes, sir.
So what does that mean is okay.
So that means
So
so for
X
this
is
condition
greater
to
than
be
5
true,
or x
x
is
is greater
greater
than
one
than
5
minute.
or x is less than 2.
no.
Yeah, this
No, no, or
no,
x
not
is
less.
greater
Why
than 5.
not less than? Or x
Why
is
x
great
is
or
less than 2?
greater than equal to, right? See,
Yes,
this
yes,
both
both
are the
are
same
greater.
expressions,
Yes.
right? So this inequality is fine, right, for both. See,
No,
whenever you
yes,
are
sir.
doing generally, see if you find out like this, right? X square minus let's say minus 7x plus 10 equal to 0. So how you write is like this, right? Equal to 0. So how you solve this equation? Whenever it's equal to 0, you can say x is equal to 5 or x is equals to 2, right? You never say x is equal to minus 2. So this inequality also holds true here. So same thing. You're getting what I'm saying?
Yes, sir.
Yes, yes, yes.
Okay. So this can be provide. What you need to find is probability that x is greater than or equal to 5 or x is greater than or equal to 2. That is okay. Until this
Yes,
is
Yes,
sir.
sir.
fine, right? Now your x was the random variable and this was the probability of x, right? So okay. So and this is, let's say 10, it's 0, it's 1 by 10, and let's say 5. So whatever greater than 5,
0.5.
that should be there,
0.5.
right? Okay.
So when we
Yeah.
solve a quadratic
Or means we will be
general,
taking union.
Or yeah, then
so
what will be, whatever it will be, right?
so
Yes.
when we solve the quadratic equation, so suppose we just have the inequality x minus 5 into x minus 2 is greater than 0. So the range of numbers which satisfy this inequality is minus infinity to 2 union 5 to infinity, right? In general, so if we just remove the concept of probability, so in general, if we are just considering the range, so shouldn't it be like the range of numbers which satisfy this inequality, that should be minus infinity to 2 union 5 to infinity, right? So shouldn't we be considering the part which is less than 2 as well? Because if we put any number which is less than 2, so both of these expressions are negative. So in total, the expression x minus 5 into x minus 2 will turn out to be positive. So if we put 0
Okay.
here,
Okay.
this expression will be positive. So basically, for values less than 2, this expression turns out to be positive. So that is also a case. Shouldn't we be considering that as well?
So what you are saying is, if you have, let's say x is greater than, so x, whatever the values are greater than x here, or and whatever if you have less than values there, right? Okay, can you
Yeah.
tell me that x should take greater than 5 and
Yeah, and
or
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 x
x
should
should
take
take
less than 2, because for
2?
both these
You are saying
values,
like this.
yeah, so for both the range,
Huh.
for this range of values, when x is less than 2
Hmm.
and when x is greater than
Hmm.
5, this expression
Hmm.
x minus 5 into x minus 2 will always be positive.
No, let's say you are having values x is less than or equal to 2.
Yeah.
Huh?
Yeah.
Suppose 1. So
Yeah.
so then this will give you negative values, right?
No,
If you
sir.
put
1
1
minus
here,
2 is
what?
-1 and 1 minus 5 is -4. So -4 into -1 will turn out to be +4.
That is
Okay,
all
okay.
okay, but these are the factors for a
But
given quadratic equation. And
Yeah.
if you took x minus 2 means that this factor will become x plus 2 and then this given expression will be a different one then.
No, how will it?
How
No, it
come
will
means
not.
that will
So
be x, if you are considering this condition x is
yeah.
less than 2, so this will become x plus 2 and x minus 5 into x plus 2 is not x square minus 7x plus 10, it is x square minus 7x
No.
minus 10. No work, no.
Why
That
are
will
you
be a different
considering it
quadratic.
as?
That will be a different
Okay,
quadratic.
okay.
That in
So, sir,
We
general,
are
sir,
not
sir.
making it
see,
x
Okay.
plus 2,
don't
I
consider
feel.
only this statement.
Sir, the
Why you are
fights
considering
apart,
only
can
this
we just come
statement?
back to our
Okay.
solution? How to do that?
Yeah. Sorry.
Yeah.
Okay. Leave that thing. Okay. So, okay. What I am saying is, okay. I will just wanted to know that Rachita, what, let's say, if you are we are taking your approach, then what will
Yeah.
be the answer? Then I
So
will talk about this also. Yeah.
okay. So
So
if we
suppose this,
yeah. So if
this is your conditions.
yeah. So
So
if we
find
take
probability
this,
that.
then the probability, this expression turns out to
Sir,
be
we
probability.
can't consider this
Yeah.
condition here. She is only considering the statement x minus 5 into x minus 2 greater than 0. That is not the only statement that we should consider. How we got that statement? We got that statement from a quadratic x square minus 7x plus 10. So how can she consider now x plus 2 greater than 0 here?
I am not considering x plus
See,
2 is greater than 0.
when you are considering
Okay.
x less than 2, in
So
general, if you
actually,
have only this equation, x minus 5 into x minus 2, then it is okay. But this expression we have derived from a particular quadratic. Will
yeah,
this
so that
quadratic be
quadratic,
satisfying your value? Tell me.
I
Will that
am sorry.
yes, that you should first check.
So the random variable x is defined over
Equal
0
to 0
to
is
10.
also there.
Yeah, so if you put in
I think what I suggest is, can you really map out both the suggestions and we can discuss that one.
So in, see, whatever she is also saying, it will give the same. It is giving actually the same answer. So she is saying greater than 5 and less than 2, right? So she's considering these two regions. So it is this is 0.5 and here it is
and that is
0.2.
0.2.
So if you do it's 0.7, and in this case, right? See, this case, x is greater than 5 or x is greater than equal to 2. But in this case, what is happening is no region was same. So if you know that OR principle, na, that means union. Whenever you have a union there, how you find out the probability is that probability of A union B is probability of A plus probability of B minus probability A intersection B, correct? So in this was our general expression, right, for union. So whenever x is greater than or equal to 5 or x is greater than or equal to 2, so this region is this one. So this one, right, this total region. So in this case, what is happening is point from 2 to so how much it is? Okay, 2 to 10, 2 to 10 it's 0.8, right? This total region from 2 to 8 is 2 to 10 is 0.8 plus what is x is greater than or equal to 5, it's 0.5, and minus what is the intersection of these probabilities. So it is again guys, why am I getting that wrong answer? Okay. Just a moment, right? Maybe I need to check once. So x square, what was that expression? 10 is greater than or equal to 7x. Okay. So yeah. So all of you got this answers correctly, apart from Ruchita.
Sir, it was my doubt.
No, not Weibo, not Weibo. So others are saying something, right, about this inequality. Maybe I'm forgetting something here, I guess. But yeah, I just wanted to know. somebody was talking right about why it should be greater than or why it should be less than or equal to something. Okay, those who don't have this doubt in this question, those got these answers correctly or not? These equations. Huh? Hello?
Yes, sir.
You got it correctly?
No, I have not attempted.
No, like lot of people are there. Somebody was actually saying right. Manjusha, I think, was saying about this equation. Then Robbie also was
No, I
there.
haven't
Sir,
reached there.
I'm concerned about negative values of x. When she's saying
No,
x
that's
is,
okay.
then it is not
Yeah,
valid.
actually, the thing is, this is inequality, right? So
And
whatever
if we
their
consider our the
no, but have
interval
you guys
given
solved this
in our
problem?
interval, I think.
I think so, sir. I got the answer, sir. I think so.
Can you
I
please
got.
explain?
I got. So I think so. What the inequality was x minus 5 into x minus 2 is greater than equal to 0. So there are two quantities. Either these two can be positive, so the multiplication will be positive, or either these two quantities will be negative, so their multiplication will be negative. So considering the first case that these two are positive, so we will get x greater than equal to 5 and x greater than equal to 2. Ultimately, we will get x greater than equal to 5 in the union part. Considering the second situation in which both are negative, we will get x less than equal to 5 or x less than equal to 2. Taking the union, we will get x less than equal to 2. So the part is we are considering the part which is less than 2 and which is greater than 5. So less than
So
2 will be
that's
0.2,
what
like
she was
greater than
saying,
5 will
right?
be 0.5.
Yeah, so this is
Yeah.
what
So
exactly I
that's
was
what.
trying to say.
Yeah,
Rachita
I
was
got
saying
it
that
now.
the same thing.
I was,
Right. So whenever there is inequality part is there, so you have.
yeah, I got it.
So
Thank you.
either you can do like this, right? Whatever
Yes, sir.
Rachita knew about that mathematical part, so she told you directly that it should be like this, right?
Sir. Yes, sir. Yes, sir. I got
Or
it
you
now,
can
sir.
think about like this. So it should be having that positive thing, right? Greater than equal to zero. That means your answer always should be having positive thing. So okay, now you can again slowly tell everyone that what you did.
Who, sir?
Okay, so that everyone will understand. Yeah, you understand, it's okay. I think others did not try this question. I thought everyone has tried it.
Okay,
So
what I did,
can you
sir.
Yeah. Now you what you understand.
Yeah. So what we did in this question that we are given
So
the x.
we can write it. Yeah.
Sir. So we are given we have to find the probability and the equation is that the x plus 10 upon x greater than equal to 7. So we have to convert this equation into a variable which is known, which is x. We don't know about x plus 10 upon x.
Correct.
So converting it into the single variable x, we have to solve the equation. Solving the equation x square plus 10 minus 7x, we will get the value of equation. We will get x minus 5 into x minus 2 greater than equal to 0. So considering the two situation, either these two quantities will be positive or either the two quantities will be negative. So if we consider the two quantities will be positive, we will get two values x greater than equal to 5 or x greater than equal to 2.
No. How can two quantities be negative?
Sir, actually,
Okay,
sir, if we
just a
take...
minute. So first of all, consider this one. So who don't understand this one, right? So this thing should be there, right?
That's
So if
okay.
you
That's okay.
here until this is fine, right? For
Yeah.
everyone,
Yeah.
x minus 5 and x minus 2. Now in which cases you will get what does this mean by inequality? This inequality means it should be
Non-negative.
always positive. Yeah,
Yeah.
non-negative means
Yes.
it should be positive. So
Yeah.
whenever you will be having x greater than 5. So whenever x is taking values greater than 5, okay. So let's say 6 minus 5 and 6 minus 2. It will always be positive, right?
Yeah.
So whenever you are having values greater than 5, so it will always give you the positive numbers 6, 7, 8, 9, or in this case we have to go until 10. Right?
Yeah.
Correct?
Yeah.
Or yeah. So what? So first condition is your x should be greater than 5. In this case, you will be getting this inequality, right? Greater than equal to 0. Right? Or 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 if these all both quantities are, so one is negative and one is positive, it won't be giving you this inequality, right?
No. I'm
So
just
in which
questioning
case
that.
it will happen?
No.
Yeah, okay.
I'm just questioning the option you have for talking about like that, because it should be a solution for the quadratic equation. No, you cannot just iterate it on a different value basis.
No, it's not iterating actually. See, whenever you are having this kind of things, everybody knows about this, right? Equal to 0.
Yeah.
In this condition, you are directly saying x is equals to 5 and x equals to 2.
Yeah.
Because we know it from repeatedly we did this for
That's right.
Sir,
so that's
this
why
much we understood, sir. After that, how will we get the 0.7 as answer? What is the conclusion part of it?
Sir, what will happen to values
I'll
x
tell you.
equal to 3 and x equal to 4 if we consider the condition x is less than 2 and x is greater than 5? Then what will happen to the between middle two values?
So whenever x is greater than or 2 equal to 2 and x is less than equal to 5.
As she said, we are considering x is less than 2.
Sir,
so in that
you
case,
just
in that
have
case,
shown
we'll get
graphically
positive.
0.7. No, you have shown graphically 0.7. What is wrong in that?
Because that is also correct. X is less than 2. But then what will happen to values 3 and 4? How we can consider that?
So 3.
Sir,
So
x can take any value, but not between 2
then
and
the
5.
condition will become x is greater than 5 and x is less than 2. So what will happen to the values 3 and 4?
So for 3 and 4,
So
this
that's what
value
I'm
will
saying
not be
you.
satisfied.
3 and 4
This
will not be
expression will
but
not be
they,
Yeah, it will be
those
satisfied.
negative.
values, those values are valid.
Okay, just a minute. Oh, arre, don't make noise. See, I'm telling you guys, right? Okay, I understand what you're trying to say is. So what I'm saying is, when you'll get the positive number, so whenever you are doing this, you should always get the positive numbers, right? So how many cases are there? Either both these brackets. I'm saying that brackets. Okay, if both of these are positive, then you'll get positive, right? Or if one of them is negative, you'll get negative, right? Because this is a multiplication. Or both of them are negative, then you will get positive. So you have to consider only these two cases, right, for your answer. So what I'm saying is, whenever you are having x is greater than 2 and x is less than 5, so which are those values? These are 3 and 4, correct? So if you put 3 here in this equation, let's say, so 3 minus 5 and 3 minus 2. So what is this? Is negative, right? Minus 2, and this is positive. So it will be minus 2. Then it is not satisfying this condition, right? This inequality condition.
Okay.
Or in that sense, let's say we are taking 4 minus 5 into 4 minus 2. Again it is minus 1 into plus 2. It's minus 2, right? This is not satisfying your condition, this condition.
Okay.
Correct?
Okay.
Now let's say, is it going to happen like this? This condition, it's in our set, it's not going to find, because to have the negative values here, it should be actually there is no x here to get this condition. Now for less than 2, how many values you can take is here 1 and 0, right?
Right.
Correct. So 1, whenever there is 1, so let's say 1 minus 2 and 1 minus 5. So it's minus 4 into minus 1. It is giving you the positive value. And again for 0, so it is giving the same thing, right? Positive value. So ultimately, what is the solution here? Whenever your value x is taking values more than 5, this inequality, it is satisfying, right? It is satisfying this inequality. And whenever you are having x is less than or equal to 2, in only these two conditions, your inequality is getting satisfied. Correct?
Okay.
So what is this mean by here? On graphical terms, should be like this, right? X and So our condition gets satisfied when x is taking values more than 5 and x is taking values less than 2. So more than 5 means this region and less than 2 means this region, correct? And in this region, since it is a uniform distribution, everywhere it is taking value like same value it is taking, right? So it's 2 by 10 here and it's 5 by 10 here, right? Or you can say 0.2, it's 0.5. So if you
And
add
now we
this,
have to do union of this, right?
yeah. So or because since either x is taking values 5 or x is taking values less than 2, right? So in this case, if you take the
And
this condition, right, union also, here no intersection part is there in this case, correct?
Disjoint.
So in this case, you will be getting this probability of A plus probability of B if these are the two events. So I can define one event as x is greater than 5 and the other event is x is less than or equal to 2. Getting? So if you
in
don't know
this case,
inequalities, right? So if you don't know inequalities, then you can just do like this. So only will always be only 4 cases, right? Whenever you are solving in any inequality, there will only be the 4 cases. What I told you. So you can just go there and I think it is quick, right? If you don't know how to solve that, you can do that thing.
Yes, sir. Yes.
So in this, if it is given that it is uniformly distributed between 0 and 10, so what is the sample space? It will be
Sample
0, 1, 2,
space.
3, 4, 5, 6, 7, 8, 9, 10, or it will be 1, 2,
Yeah.
3, 4, 5, 6, 7, 8, 9, 10.
No. It will see in this case actually sample space defining, right? Because this is a continuous variable, random variable. This is not
Yes.
discrete. In discrete cases, you can say 0, 1, 2, 3, 4. In
Okay,
this
sir.
case, it is taking all the values between 0 and 10. It will be 0, 0 0.1, 0 0.001, everything.
So the inclusive and exclusive doesn't matter here, no? Means open
Yeah,
bracket or closed bracket are same.
no. Yeah, everything. So in continuous random variable, you should not be worrying about these things. That include because it will always be. See, that's why in PDF finding out a PDF, right? It is very difficult. So ma'am has mentioned somewhere, I guess I don't know. You cannot find exact probability that x equals to 2.
Exact will be
It
0
will always
only.
be equal to 0. Yeah.
Yeah,
So
because the area is
that
0.
means, yeah. So area 0 means what? You cannot find the point value, right? So because it is not discrete, so you
Yes,
have
sir.
to take cumulative distribution there
Okay, sir.
always.
Okay, sir. Thank you, sir.
So in that case, everything should be inclusive. You cannot say between means 0 and 10 means you include excluding 0 and including 10, because these points are not defined there actually.
Okay, sir. Yeah. Yes, sir.
So
Yes,
you
sir,
can say that okay, probability that x is less than or 0 or less than or equal to 0, or probability that x is less than or equal to 10, or like that. You cannot, you should not say like probability x equals to 10. This is not defined there itself.
Yes, sir. Thank you, sir.
yes, sir. I have one doubt in supplementary quiz solution. Quiz 2 set, question number 2.
So which one? Which supplementary?
Supplementary quiz solutions.
Quiz solutions. Okay. Which you are talking about? Like
Maybe qualifier solutions.
April qualifier or term? Not from April qualifier, right? Because these two are different actually portals right now.
Okay. So can I
You
post
are from term one or qualifier?
term 1?
You're from term. 1 minute. I need to. Just a minute, I'll open it. Okay. Supplementary contents. Quiz. Which one?
Uh, quiz solution. Also, can I paste the question
Quiz solution.
in chat?
Okay. Okay, you can tell me the question itself. It's not a problem. So maybe I'll just try. Okay, here. Quiz two, huh?
Uh, quiz 2. Yeah, quiz 2 set 2. I think the third one, I think. Third one or fourth one. One of-
Okay, okay, let's see. Both are these are okay, right? So yeah, let's see. This one, this paper,
No, quiz 2, sir. Quiz 2. It is from quiz 2.
quiz two. Okay. This paper. Okay. Tell me which question.
Yes, sir. So, second question.
This one. Okay. There are four pairs of shoes of different sizes. Each of the eight shoes can be colored with one of the four colors. This one, right?
Yeah.
Okay. Brown, white, green, and red. Find number of ways the shoe can be colored so that at least three pairs do not have the same color. Okay. You just tell me what is your approach there. So let's. We had four uh, four pairs of shoes. Huh?
Yeah.
So okay, I will just give you. I will tell you that four pairs of shoes means total of eight shoes, right?
Right.
Uh, and then you have different colors. Let's say brown, gray. I don't know which one is there. Red and let's say blue. Not blue again. Uh, so tell me some color. Okay. Sorry.
Yeah.
Brown, gray, white, green, and red.
Brown, white,
Brown,
green, and red.
white, green, and red. Okay. So these are the four colors. Now they asked the question that at least three players should have
Different.
okay, should not have this or should have different color. Okay, that is okay. So can you tell me how you approach this problem?
Yeah, so sir, actually there are two cases. In first case is like three pairs of shoes will have, I mean six shoes will have different color, and case two is like all the eight shoes will have different colors.
Correct.
Yeah. So and for each pair is independent. I mean, uh,
Yeah. So whatever color we will be having on each pair, it should be independent of the other. That's okay.
yeah, yeah,
Or that means three or four, right?
yeah,
Either three pairs. So this is pairs.
yes,
Either three pairs or four pairs should have different color. That is the question. Correct.
yes.
Now tell me what is the answer for this?
Yeah,
For three
three
pairs.
pairs. Yeah, so for three pairs, so actually, so first pair will always have same color. So it will
Why
all.
always have? Always why? Okay,
Uh,
I think you did mistake there itself. So I think whatever you did is correct for apart from this, I guess. So any of these four pairs, right? Because we should have one pair which is having the same color.
yes,
Correct.
yes.
So which one is that pair? That is important.
That is,
So
yeah,
it
that
should
is
be
4C1. That is 4C1.
4C1.
Yeah,
Yeah. Now tell
yeah,
me. Yeah.
4C1
So if it
and
is 4C1,
okay, 4C1
so
and
4C1.
okay, and since only
So
one
out
color
of this four,
out of four color, only one color we can choose. So that you okay, sir, I got it. Now it is like 16. So my doubt was 16 only. How did 16 came? So yeah,
yeah,
now I am clear.
yeah. So 4 into 1 here,
Yeah,
4
and
into 1 here,
yeah,
then 4 into
then
3, 4
three,
into 3 for remaining pairs,
two, three,
right?
four, three.
And
Yes,
this 4. And yeah, and for 4 pairs, it should be always be 4 into 3 and 4 into
yeah, yeah.
3.
4 into 3, 4 into 3, 4 into 3.
4 into 3, 4 into 3, and 4 into 3.
Yeah,
And obviously it is and, right?
yeah, and yeah, it is and. So here one question is like
Yeah.
how it is and
So
shouldn't it be or, since it's an
so
independent?
no, or no, it's no, yeah. So it is independent, but what you're saying that okay, first pair is having different color. You are not saying or second pair is having. So if you say or, that will give you different meaning. So what we wanted here is three pairs should have the same color, sorry, different color, and one is so what you're saying here, and one is having different, right? You're not saying or is having different color. So see, first pair is having different color, and the second pair is having different color, and third pair is having, and fourth pair is having same color, like that, right? You're saying whenever you're saying like this,
Yes.
it should not be all right.
Yeah. So from the question, it was not very obvious like that it is like and
No, but whenever you are see in English language, so how can you say that or? Whenever you're saying you or, right, then it will be having some different meaning. So or means either this pair, like either first pair is having different color or second pair is having different color. Then that meaning is that means, let's say my first pair is having different color, or my second pair is having different color. So whenever you're saying or means that means first pair can have same color and
but
the
here
second
sir,
pair can have same color.
but here sir, it is telling like at least three pairs should have different colors. So
So and only it is applicable here. Okay, so it will always be and. So okay, that we are not going into detail of that now. So okay, so
okay,
this is
thank you.
so this should be the answer. And here you are saying or, right, here three pairs or four pairs, then it is having addition. So you have to add these
Yeah,
things.
this will be addition because at least three, so it can be three or four. So
Or you here you are saying, right, at least three or,
uh,
here it's or, here it is and. Okay.
within this, okay.
Within no, whenever you are saying this thing, right, the first is this or the second is this, then it is having uh okay, no, don't go into that. Let's see.
Okay.
Okay, anyone having these different doubts?
Some mock 5 question number
So because this is last minute talk, so
5.
we should not go these things.
Mock
Which one?
5 question number 5.
Same set?
No sir, April portal. April qualifier.
Okay.
Mock 5
Just tell me
question.
that thing, okay? April qualifier, and because
Yes.
I don't know. Mock 5, huh?
Ah.
Mock 5.
Question number 5.
Mock 5.
In mock tests.
Huh?
Yeah.
1 minute. Just opening. 5. Question number 5. Okay.
Yes.
In a bean, 45% of the balls are blue, while 55% are red. Among all the balls that are there inside the bean, 40% are metallic and 60% are plastic. Okay. A ball is randomly chosen from the bean. What is provided that the ball is blue and metallic if out of the metallic balls 60% are red. Okay, so okay, tell me your thought on this.
So I got answer
So first of all,
0.4. Just wrong.
no, don't say the final answer. We'll go later there. First of all,
Yes.
we'll start. 40% are blue and 55% are red. So
Probability
45
of
are.
blue balls being is 0.45 and red
So
balls
this is.
being is 0.5.
Then we know additional information that how many are metallic and how many are plastic.
Plastic.
Right.
So shall we
So
take it
40
as
are metallic
probability
and
of
60%.
metallic and plastic is separately 60 and 40. Yeah.
Yeah, correct.
That yeah.
And
60.
okay. right?
60%
60-40.
red are metallic.
Now, and you know that out of the metallic balls, 60% are
60% are red.
red. So, correct.
This is probability of R given M. So that
Okay, I will go slowly ahead. So we know that out of this red balls, 60% are metallic, and uh, so obviously the 0.4 times, like 40% of the red balls are plastic. Now, so yeah, so this is
so we
the
can
question.
take that statement as a probability of red given metallic is 0.6. No.
Yeah, so if you can draw this diagram, that will be helpful in solving.
Yeah, this would
Otherwise
be
you
easy.
can go from the, yeah, so otherwise you can go with this defining events. Let's say probability of b is my event that you will get the red blue ball, right? So what is this probability? It's 0.45. Then probability of red ball is 0.55. Then probability of metallic is 0.4 here, right? The probability of plastic is 0.6 here. Then probability of uh, red given metallic,
Given
right?
metallic is 0.6.
Sorry. I think I'm writing it wrong, I guess. So probability of metallic, right? Given the red, huh?
This is where I'm confused.
I just read the statement. Out of the metallic, 60% are red, right?
Yeah.
So, okay, 1 minute. I think I did it wrong here somewhere. Out of the metallic balls, 60% are red. Sorry. Here.
So R given
Out
M,
of
right?
the total metallic balls, yes. So out of no. Uh, these are red. So these are blue. Okay. So given that it is a red ball and it is from metallic, so r given m. This probability is given 0.6. Correct.
Yes.
Correct, right? So what
Yeah.
what information we are given is uh, given that it is a so out of the total metallic balls, 60% are red.
Yeah.
So yeah, so okay, so how many then metallic red balls are there? How many total metallic balls are there?
0.24.
Yeah, so it should be probability of r given m into probability of m, right? So it should be 0.6 into 0.4.
Yeah.
No. This is metallic given red. Okay. I'm defining something wrong here, I guess.
And it should be other way around, no?
This is
Probability of red given that it
so
is a metallic, no?
see what is the probability that the ball is blue and metallic if out of the metallic balls 60% are red.
Out
Yeah.
of metallic ball, 60%
So
are red. So yeah, the graph you have drawn is perfect. In defining, we are making some error, I guess.
So how do you translate that statement
here
out of the
no
metal?
this okay, 1 minute. I'm doing that. So first this is okay, this is fine. This tree
Yeah, this
diagram,
is
right?
fine.
This is okay, I guess.
Correct.
So here total you are going to find the probability of red balls actually. So this is 0.24, right? Probability of red balls
Given that it
Given
is
that
or
it is a
metallic red
metallic.
balls.
Yeah, that's the way it should be, no?
Yeah. So
Probability
this
of
should be
red
it should
balls.
not be like this. Yeah.
Yeah.
It's probability of red balls given the metallic.
Given that it is metallic.
Yes.
Yeah. Probability of red ball given its metallic, it is 0.24 now. So this one is total. Correct. Okay. Now what we need to find out is probability of
Blue ball given
What is the probability that the ball is blue and it should be metallic?
So B given M.
Okay, B given M. So it should be direct, right?
Yeah, so that I
total
did.
metallic ball is 0.16, right?
Okay. So in making
What
the
is the
graph,
answer?
now it is correct. I got it.
Answer is it correct?
Yeah, correct.
Yeah, that is correct. Yeah, so this information actually not needed.
I drew the graph
This
in
information
wrong way.
was not useful.
Yes.
Yeah, maybe, I understand. So yeah.
So the next question, sixth question. Sixth question, sir.
Sixth one, same paper.
Same paper. So immediate
Okay.
next question.
A machine learning model detects whether the given image is an image of a dog or not. Okay. It's found that given an image of a dog, the model predicts it to be a dog in 90% of the cases. So, given dog, and it is predicting it correctly. So what is the probability of, let's say C is correct and given dog, right? It's 0.95, right? Correct. It is found that the given an image of a dog, the model predicts to be a dog in 95% of the cases. On the other hand, if the image is not actually a dog, it shows it to be a dog 30% of the time. So let's
D
say,
complement.
okay.
C given D complement.
So it should be. Okay. Don't say it's correct. Actually, let's say it is predicting it's a dog. C is the event that it's predicting it's a dog. Not correct, because then in this case it is given the, it's not giving the dog image, but still it is predicting it's a dog.
Yeah,
right?
this is an error.
So let's say C is something that it is predicting dog. C is it's predicting dog given
Prediction.
dog.
Okay.
So it is predicting dog given dog. Actually it is a dog, and it is predicting dog
when it is not actually a dog.
When it is not actually, this is 0.3.
Yes.
Right. Suppose an image is randomly selected from a group of 100 images in which 40 are dogs. So yeah, then we know that probability of dog is 0.4, right?
Yeah.
Correct? Because out of total 100, there are 40. So probability of not dog is 0.6 now. Correct? That is okay, right?
Yes. Yes.
Okay. If the machine learning model predicts it as a dog, what is the probability that it is actually a dog? Okay. So, okay. So. Okay.
Sir, this question was also given in the mock of July 11 quiz.
So first we need to find
Actually,
the probability of prediction.
First of all, there are two papers. No. Okay. We'll come to the question, but yeah. So actually, there are two types of students here. So one is from April qualifier, and one are from like from the previous qualifiers. So some might have seen this problem before, and some might have seen this problem now. So yeah. Okay. Again, what we need to find is, okay.
So
Maybe
first
I'm
we
doing
need to
something
find,
wrong,
I
or
guess, probability of prediction, so that we can find that it is actually a dog and it is predicted right. That is the question.
So it's found that given an image of a dog, the model predicts it to be a dog in 95% of the cases, and on the other hand, if the image is not actually a dog, it shows the image to be dog 30% of the time. Suppose an image is randomly selected from a group of 100 images in which 40 are dogs. Okay. So yeah, okay. I'm getting the answer. What is actually the answer? But okay, let's see. We need to find that. Uh, to find that it should
It
be
is
the
actually
image of the dog. Yeah. No, no, not actually dog. It is predicting a dog.
given that it is a dog. So
The machine learning model okay, it is actually a dog, huh?
yeah. So our prediction should be
Can we tabulate that one as a can we tabulate the statements in a table?
No, 1 minute, just give me a minute to think. Some sentences are I'm not feeling it right. Or it's found that given an image of a dog, the model predicts it is to be a dog in 95% of the cases, right? On the other hand, if the image is not actually a dog, it shows the image to be dog 30% of the time. Okay. Suppose an image is randomly selected from the group of 100 images in which 40 are dogs. Okay, a machine learning model predicts it as a dog. It is probably that it is actually a dog. So, am I defining it correctly? So, given an image of a dog, okay. So, actually, it is a dog. Okay. So, given an image of a dog, it is predicting. First statement is it is found that given an image of a dog, the model predicts it to be a dog. So yeah. So whenever
we
there
have
is
defined
actually a
correct.
dog image, yeah. No. I think I defined it reversely. See, so given an image of a dog, so whenever there is an actual dog, right? Uh, the model is predicting it as a dog, right? 95% of the cases. Is that okay?
No, so I guess the previous definition
Sir,
was
it
correct.
should be
Yes,
the other way around. No?
so the previous definition
Previously,
was
you had
correct.
yeah,
Okay. Oh, I'm also
because our
getting confused.
prediction is
Okay,
we are
let's
finding the
but
probability of
see
Yeah,
if yeah, given an image of a dog, so it is let's say
predicting
predicting
correct.
is
it is predicting correctly,
Yeah,
huh?
yeah.
It is
yeah,
predicting
yeah, yeah.
it as dog. So now in this case, no, not giving the image
Not
of a
given a
dog,
dog, and prediction is still correct.
still
Prediction is,
still
yeah,
not correct, but yeah, we can say it's a
yeah.
dog. So correct if you are saying that there is a problem, right?
So, so,
So
so we can define
huh,
C as the machine learning model predicts it as a dog. So we can interpret it
dog,
as the
yes,
machine learning model predicting is it as a dog, given it is actually a dog.
yes.
Yeah, and
uh
given it is not a dog.
so
Yeah. So
yeah,
So
that
first
now
that
one
we
is
just
I
have
did
to find
see.
out. So we can just find out
That it should be a
probability
dog, na?
that D given C.
yeah, we have to find that. No?
Probability D
Okay,
given
okay, okay,
C.
okay,
We
okay.
just
Yeah,
have to
Yes,
find
yes.
out.
just a minute. So okay, 1 minute. I'll write. I'll if the machine learning model. Okay, it is already predicted the dog. So what is the
So
probability that
what I
it is
suggest is
actually a
you
dog?
just
Okay. Yeah.
you
No,
just
no, no, sir.
put it in
Okay,
a 2 by 2
1 minute.
matrix, then and the statements are becoming clear.
No, so it's
If you
so.
draw the tree
Uh,
diagram, the
One
question
minute.
becomes easier.
Yeah, that's right.
Okay, I will do that in that way also. So first of all, I think I did mistake here in reading this statement. So here
It tends
it is
to
given
go
that if
wrong,
the
sir.
machine learning model predicts it as a dog, if the machine learning model predicts it as a dog, so it is already predicted. So it is given that it is given that it's predicted correctly, right? Or it is prediction. It predicts a dog. It is given that, and we need to find that it should be
It is
actually a dog,
actually a
right?
dog.
It should be
Yeah.
correct, right? Yeah. So this should be the actually it's a dog, right? So in that case, uh, the we can write is probability of D intersection C, right? and divided by probability of a dog. So sorry, this one, right? Still I'm not
So we can use Bayes theorem here.
Yeah, we can use Bayes theorem, I think.
Instead of that probability of D intersection C, we can do it as probability of C given that it is D into probability of D plus
same thing, right? So
because we are
okay.
given that
I understand
values,
what you're
that
saying
is
is.
why.
No, okay, that I understand, but yeah, so we can have this probability of C. How can you find out probability it is correct? So it should be probability of C given D into probability of D plus probability of C given means D complement into probability of D complement, right? This is your denominator.
C.
And what is your, so what is your probability of D intersection C? So in the other way around we can do, right? So if it is
0.95.
probability of C given D is, it should be probability of C intersection D divided probability of D. So that means here probability of C given D into probability of D, right?
Yeah.
So Bayes theorem is nothing but conditional probability only, right? I am doing that only, but from Bayes. So I generally I forget the Bayes theorem, so I do like this. Okay. So probability of C given D is, we know that, right? 0.95 into probability of D is 0.4. Yeah, then you can put out the values. I think it will give you the correct answers. 0.3 into probability of D complement is 0.6. Yeah, I think this will solve the problem. Okay, in tree diagram method, okay, I think in tree diagram it will be somewhat difficult, right? Okay, so we know that dog and not dog. So here we got this, right? This is correctly given 0.4 and 0.6, and if it's correctly mentioned C given dog, C not dog, this is 0.95, 0.3, right? Oh no. Tree diagram method, I don't think it's useful here. We are not getting it properly, right? So okay, those who did it from tree diagram, can you tell me how you
So
did that?
visualizing it is very difficult.
Yeah, here in this case it's very difficult, right? No, those someone was saying, right? So have you solved this with the tree diagram? Okay. So if you have any other question, tell me.
So I have one question. Activity question 11.5.
11.5.
Question number 6.
Question number 6.
Yeah.
Variance of y. Okay.
Yeah. So my doubt here is that it is given that it is the PMF of binomial random variable. So yeah, expectation is coming out to be fine via the formula summation of x into probability of x minus x. So by that, since it is given to be a binomial random variable, so this expectation of y is also equal to n into p. So I tried finding out p from that, and from that, if I'm using the formula of variance n into p into 1 minus p, my variance is coming out to be different than when I'm calculating it from the first principles method, like from the formula expectation of y square minus expectation of y whole square. So I did not understand why is that the case. Then I also tried to find out the probability of success using PMF, but the P was turning out to be different for each of the case. So I did not understand how is it happening.
Let's so this is the value you got from that NP 1
expectation.
minus P, right?
No, this is the value I got from
sorry.
first principles.
So this one,
Yeah, this
1.04.
one. Yeah, so this is the
This one
value which I
from,
got from the formula, expectation of y square minus expectation of y whole square.
this one, expectation of y minus, sorry, expectation of
Expectation
y
of
square.
y square minus expectation of y whole square.
Yeah, yeah, this
So
one,
this is
right?
the value. Yeah,
So you did it in this way, so you got it 1.04, you are saying.
1.04. Yes. Yeah.
Okay, can you just tell me the values here? So probability, right?
N was 3.
0, 1, 2, 3.
Okay, 0, 1, 2, 3.
Huh.
Okay.
So
Just a
no,
second. It's a 0.15, 0.35,
hmm.
0.25, and 0.25.
Okay. So how much variation you are getting in this values? Like large variation or very small variations?
So large variation from the formula n into p into 1 minus p, I was getting 0.74 something.
Okay, okay. So first of all, you need in this case, uh, this okay. Mm, okay. So variance of y in case by using this n, this value, sorry, n p into 1 minus p. If I wanted to find out that,
Yeah.
then how can I approach to this problem is, let's say probability that y will take value equals to 0 is 3c0 p raised to 0 into, okay, I'm saying this is q, okay, that is okay,
Yeah.
right?
Yeah. Yeah.
Q raised to 3.
3. Yeah.
Hmm. Okay, okay, which one is maybe I will go for this one. This will be the simpler
Probability
calculation,
3.
right?
Yeah. Yeah.
Okay, sorry. So yeah, so it should be 0.25 is equals to, what is the value of 3c3 is 1, right?
Yeah. 3c is 3 is 1. So that is p cube is equals to 0.25.
So yeah, p cube is 0.25. So then what is the value of p here? Okay,
I'll just
1 minute,
calculate.
I'll calculate. 0.6299 something.
Yeah. So 0.63
So
if
let's say
we are
let's say
rounding
let's
it
say
off.
0.6. Yeah. Okay.
Yeah.
So this is the value of p. Then what is
Yeah.
the value of q? This is 1 minus p. It's let's say 0.27, right?
Yeah. Yeah.
Or 37.
0.37. 0.37.
0.37. So then if I'll put 3 into 0.63 into 0.37, what is the value? 0.63 into 0.37 into 3 is coming out to be
0.7.
Oh, is it?
Yeah. So
1 minute, 1 minute. It should not happen actually.
So I tried finding out p from probability y is equals to 0 as well. So in that case, p was coming out to be different. So in all the cases I tried, the value of p was coming out to be different. So
Okay,
that is
okay,
why.
okay, okay, maybe. Okay, okay, okay. So yeah, yeah. Okay, I think this table is given na. So
Yeah.
that there is a So whenever we are giving tables, maybe we calculated by using one formula, and we
Yeah.
are given the answer here. We did not, I think, verify that. Actually, it should in every case it should coming out to be same, right?
Right. Exactly.
Why something? Okay,
Since
let's
it was
try with
given
y
it to be
equal to
binomial, I
1
tried
here.
with formula.
Yeah, correct. So 3c0, yeah, that can happen actually. Mistake can happen because
Yes.
these are
Yes.
very small values, na.
Yes.
So
I
due
get
to
it.
that, there is huge variations are coming. 1 minute, I'll just check out once. 0.15. Hmm. Yes. Yeah. With 0, it is coming out it's again very different. So it's p
Yeah.
coming out here is 0.4. Sorry, how
0.47
much?
approx. Yeah.
0.47. Yeah, 0.47.
Yes.
Okay. Leave that problem.
No
There is a
problem.
mistake in
I
that
get
problem.
it. So
Okay.
okay. Thank you.
Yeah.
Thank you so much.
Yeah. Thanks. Okay, thanks by pointing out. Okay, expectation you are getting same, or okay, maybe I think that is also you are getting differently.
No expectation, because I did not use the formula there, because I simply
No, but
calculate the
yeah, but somebody
expectation.
has used.
But yeah,
Yeah, then
so if
again it
someone
will
will
be
use
okay.
the formula, it will be different.
Correct. Okay, I'll note it down. Yeah, I will make changes later on. Okay,
Yeah.
for now it's okay. Okay, thank you.
Thank you so much, sir.
Yeah. Any other problems? Okay, anyone is having anything? Okay,
Mock
because you
5.
guys are having
Question
mock
number
5. Yeah,
12.
mock 5. Yeah? Question number
12.
Okay. Ricky and Sadie play a game by tossing a fair coin. If the outcome is head, then Ricky earns 1 point, and if the outcome is tail, then Sadie earns 1 point. What is the probability that after 10 tosses of the coin, this is a fair coin? Okay, both have the same points. Okay, so tell me how you have solved this problem.
So there are 10 tosses. So until both have equal points, we are playing the game. And when both players get same point, we stop. So for example, if we get tail and in first toss and in second toss we get heads, then we can stop here, right?
No, stop. No, it is not written here, right? It's stopping these things. What is the probability that after 10 tosses of the coin, both have same point? Means like all the 10 tosses are played out, and now tell me if they are having the same points or not. What is the probability that they will be having same points? So only one case is there, right? Possible.
Yeah.
Or maybe. So here there is no other case. I think 1 and 1 points are there. So after 10 tosses of a coin, uh, either like if this condition to be satisfied, the first five or for some 5 tosses are won by Reki and 5 tosses are won by Sadie, right? That should be the case, right?
Yeah. So one
So
probability.
here it is not mentioned that whenever they'll get same point we are stopping, and whenever they are not getting same we are not stopping, right?
Okay. So then
Yeah. So then this problem will again be then simple one, right? So first of all you have to find favorable outcomes, right? Favorable outcomes and total number of outcomes. So uh, so you can try out that now.
yes.
Okay, any other
So
thing?
question number 8 here in this
Sorry. 8. You have four-sided biased die number from 1 to 4. The numbers from 1 to 3 are equivalent to land face up, but number 4 is twice as likely to land face up as each of the other numbers. Suppose you are playing a game using the die. Okay, this die, if you get an even number on the die, your score will be same as the number observed. But if it is odd number, your score will be observed number -1. Okay, let us denote the sum of scores between obtained after throwing the die twice. Hmm. Okay, what is the probability that x is equals to 6? Okay. Okay, so given that it is unfair die, right? So 1 2 3, let's say it is having probability x, and for 4 it is having 2x, huh?
2x.
Or x by 2.
So 2x. So
2x.
now we get probability, individual probability for 1, 2, and 3 as 0.2, and for 4, 0.4.
Okay, okay. We can form the tables. Let's say.
Yeah, PM. Yeah. So 0.2,
So
0.2,
3x,
0.2.
3x. Okay. X value. Okay. 0.2, 0.1. Well, this 0.4. Okay. This is the okay. Now what we need to find out is,
if we get odd, our score is decreased by 1, and if we get even, we get the same as the number.
Same score. Okay. When it is even, we'll get same. When it is odd, we'll get number -1. Right? And we need to find out the probability that x equals to 6. So you have to, and only dice through 2 times. So you have to first of all, how many cases are possible there to get 6 as a outcome of like or 6 points, right? This should be 6 points, right?
So we can make one more. We
Okay,
can add one more row below this. If we get 1, then our score is 0. If we get 1 on die, our score is 0.
No. First of all, find out the cases here. Because okay, if you are trying like this, n-1, it will be 0.
Because we are going to we are concluding at the scores, so that is why if we take score.
But then the probabilities, how you are going to write down the probabilities here? If you write like this, if you are getting 1 is 0, 2 is 2, 3 is like this, right? You're doing like this, right? But then you will be having only 2 things, and then you are how you are going to do this? 0.2 and 0.8. I think you did like this, huh?
Yeah.
Then it will no. So here is points are 6. So when your points are 6, then how can you get the points as 6 in 2 tosses?
Yeah, so for that only, if we make a row of score, I'm saying that if we get one on our die, one on our dice, then we get score 0. If we get 2 and 3 on our dice, our score is 2. And if we get 4 on our dice, then our score is 4. So we are having 2 throws. In first throw, if we score 2, and in the second score, if we score 4, our score will become 6. So that is one case.
Okay. What I'm saying is, we can define the random variable y that the score is equals to 6. Huh? So y is the combination of x1 and x2, right?
Yeah.
But this is not exactly x1 and x2, but this is something different. But yeah, let's say x1 and x2. So suppose whenever there is 1 here, so 0 plus something, right? Then okay, you wanted to say that y, which values y can take as a score. So it can take 0 also, right? When both are 1. So yeah, or so this is 1 and 1. Okay. Then you can have the you can take the y can take the value as 1 also. Not 1, right?
No, sir. Score will be 2.
1 is not possible.
If we take 1 and 2.
Yeah, 2 can be possible, right?
It's possible.
Y as score as 2 is possible. So in that case, how it is possible? When first die is 1, the second die can be 2, or you can have this 1 and 3 also.
First die, 1 and 3. Yes, exactly.
But again, this can be possible, no?
1 and 3, 1 also. Yes, these also possible.
These are possible, and we are getting the score as 2, right? Any other possibilities there?
No.
Sure.
Yeah, sure. Because our fourth, our next possibility
have
is
3
y
also.
is 4. No, sir. Y.
Also, right?
No. It will have 4.
Okay, 3 is not possible. Okay, 4 is possible.
4 is possible by getting 1 and 4 on our dice. Then similarly 4, 1. 4 is also possible by getting 2 and 3 because they are
2 and 2 is possible, right?
Yeah, 2 and 2, 3 and 3, 3 and 2, 2 and 3.
This can be possibilities, right? This can be possibilities.
So
Okay.
3 and 3 also.
3 and 3 also. Yeah. So how we are going to write down the probabilities for this?
Yeah, so that.
So yeah. So okay, these are okay. This you counted down, right? These are the cases that are possible, right? These are the cases where you are getting the y equals to 6. But now the question is how we can write down the probabilities for this. Again, we have this is unbiased dice. So these are the different probabilities associated with this 1, 2, 3, and 4. Now, so in this case, whenever you are having 1 and 1, what is the probability that y? What is the probability that y equals to 1 and 1? So it will be
0.2 to 0.
It is 1 and 1. Okay, 0.04, right? So it's 0.2 into 0.2, no?
Yes.
Correct? Yeah. Now for 2, for these cases to be possible, 1 and 3, 1 and 3 will be 0.2 and 0.2, or it can be 0.2 into 0.2, or can be 0.2 into 0.2. So it's so it's 0.1, so 0.2, 0.2, 0.1. Okay, everything is 0.2 here, right?
Yes.
So it will be 4 times.
4.
So it will be 0.16. Right? And remaining, you can do the calculation, or you can say 1 minus something. 1 minus 0.2, so it will be 0.8. Is that okay?
Yes.
Okay. No. It should not be 0.8. Sorry. Okay, I'll count it up. Sorry. So 1 and 4 is 0.2 into 0.4 plus 0.4 into 0.2. Again, 0.2, 3, 2, 2, everything is 1,
That
2,
is
3, 4.
0.16.
4.04. It's yeah. So it's because y can take other values also, right? So we are just taking for 6 here, but that if y is some score, if I'm defining y as a random variable to be a score, so there can be possibly other scores can also be possible, right? But these are our favorable cases, right?
Yes.
0, 2, and 4. So which are likely to occur. So other than that also is possible, right? 4 plus 2, 6. 6 also 6 score is also possible. And then no. Some,
Okay, no, sir.
let's
These
see,
are
let's
only
see.
the cases which will be possible.
Yeah. But yes, 1 minute. I will see.
Divide that whole third column by total.
It's 0.32.
Sir, what is it?
Actually, no. Why actually this random variable? What we are considering here, the score. If you are considering y as a score, right? The different scores are possible actually. See, whatever I have written here is the which are the scores which are useful to us, right? No, there can be the possibilities that y can have other combination of scores also on the 2 dice, correct? Suppose you're having this
2 and 2, 3 and 3, 4 and 4 also is possible. Yes.
So in
so, sir, we can say that we were. It was not needed to calculate the score of 2 and 0. If we directly had calculated score of 4, that would be our answer. Y is
1 minute. Oh yeah, shit. Okay. So these are the scores you are said, right? 0 is possible, 2 is possible, 4 is possible. One other thing is 6 is also possible, right?
Yes.
So for 6, what are the possibilities? Like what are the combinations are possible here? If I'm defining random variable as a score on 2 dice, it can be having or not 2 dice, random variable after random variable which takes a score. So scores are possible at 0, 2, 4, 6 also possible. So what is probability that or what are the combination where we are getting 6? Hmm? Can you tell me 6?
So actually,
2, 4 and 4, 2. These are the two possibilities, are there, right?
so this is only that 4 score.
So, what happened?
So no, sir.
These 4 cases are possible, right? For 6. You are getting? No? We need to find the probability for 6, right? Until what we found out the probabilities for 0, 2 and 4.
Yeah. These are the cases.
So we need to find, you can directly find this 6, but now we are writing the whole table here, because you just did that, right? So for 6, then again we need to calculate the probabilities. So it will be this 2 and 4, it's 0.2 and 0.4, 4 and 2 is 0.2 and 0.4, 3 and 4 it's okay, this is 0.2 and 0.4 plus 0.4 and 0.2 plus for 3 it's 0.2 and 0.4 and 0.4 and 0.3. So sorry, so 1, 2, 3 and 4, so it's 4 times 0.2 and 0.4. It's 0.32. Okay,
so
some
0,
other scores
2
are
and 4 were not required,
yeah.
actually, right?
Yeah, it's not required. You have created. So actually, whatever you said, I have just right.
I made it mistake. Yes, my mistake.
Okay. No, it's okay. So again, we can find out, right? 0 to 4. Other scores are also possible, because since now it is again, it's not total one, right? 0.32 plus
4 and
0.3 is
4 is possible.
0.64.
Only one is left. So 4 and 4.
Score.
Score 8.
So okay, 8 is also possible. Others also, I think it should be possible. So it's 32, 32, 6. So if it is 4 and 4, then it is 0.16.
0.16.
Okay. 0.324. Yeah, okay. Okay, these are the only possible scores: 0, 2, 4, 6 and 8. And among that, we have asked about this, right? So this is your answer. It's 0.32. Okay. So yeah,
no other
doing
method to
everything
solve
like this. No. These cases you need to find. But yeah, the fastest way to solve this question is you have to just think about only targeted value, like probability that the score should be equal to 6. That means y equal to 6. So in that case, how it is possible? So you can just write out down directly like this: 2, 4, 4, 2, 3, 4 and 4, 3. Correct now?
Yes, sir, correct. Thank you.
So if you do like this, these are the only 4 cases, and you can write down probabilities for that from here, from this table. But yeah, there is no other method. You just have to write down the cases. So in case if you are asked about probability that x equals to 4, that means then you have to calculate all these things,
all the 6 values,
all cases, and you have to multiply. So that is the thing. Okay. We have 10 minutes left. So any other doubts? sometimes in probability, right? Sometimes cases are like you can't avoid those cases. You have to just make sure that all the cases you are writing it down, and then you have to calculate the probabilities. It's not like there is no straightforward answer to it.
It's a mock 4 question 12.
Mock 4. In a tennis competition involving both boys and girls, every player has to play exactly one match with every other player. It was found that 10 games are such that both the players are girls, and in 105 games, both players are boys. What is the number of games in which one player is a girl and the opponent is boy? Okay, so 10. Okay. So both are girls is how many games?
10 games.
Okay, I'll write as let's say I'll write. Both are boys is 105. Huh?
Yeah.
So this is just the same problem as that of that handshakes, right? Suppose okay, now I don't know how many girls are there. So let's say n girls are there. Okay, and let's say total of m boys are there. So okay,
Total
I
number
will
of
tell my
handshakes
approach.
possible would be n into n minus 1 and m into n minus 1.
Okay, yeah. So it will be, can say
N into n minus 1 for girls and n into n minus 1 for boys.
so that is only that thing, right? 1 minute. That is the when both are the girls. When that
Ah,
n minus into n minus 1 is when both are girls, right?
girls,
And this
yes.
is possible when uh, both are boys. So this is given. This is actually given to us. But from this, you are not going to find out anything. Is it possible? Okay, you can find out the total number of boys here. So n square minus n minus 10 equals to 0. This is one equation. M square minus how much? M. Okay, I did. Okay, m minus 105 is equal to 0. This is another equation. So what is the value of n? Can you tell me? M.
So actually we don't get a whole number, rational value.
Is it?
Yeah, so p square minus 4 is c. You get 1 minus 40, root 39. Discriminant is root 39.
Yeah, because you did here mistake. So it's by 2. So okay, when you do the handshakes, what is if you do the handshakes, so if there are total of or n persons are there, how many ways they can do the handshakes is nc2, right? So what is nc2? N factorial upon 2 factorial into n minus 2 factorial.
Yeah.
So if you elaborate this one, how you can write n factorial
N
as n
into 1
minus 2
minus n
factorial.
into 2 factorial. Yes.
This will get cancelled. So n
Okay.
into n minus 1 by 2 is 10. So n into n minus 1 is equals to 20. So it is
20.
n square minus n minus 2.
Now it is correct. Yes, sir.
Now if you can solve, you will get some value for n. Let's say n is 5 and m is, let's say, something 10. So then you have to calculate this one, n plus m c2. This will you will get total number of handshakes.
Total number of handshakes. So
Right?
we will subtract 10 and
We can
105.
subtract Yeah, correct. So yeah, whenever you're doing this, yeah, this should be there. Maybe you did mistake here, the
Yeah,
2
sir.
factorial.
Formula I forgot.
uh,
It is.
okay, that's fine. Okay, don't do that in the paper, it's okay
Sure.
here.
Sure. Yes.
Can you once again explain two sets? One is five girls and five boys that you discussed today, and also the Australian Indian son. I'm getting confused in the solutions.
10 here in the same question you're saying the
No,
10
no, no, no.
girls and
The, no. The sitting arrangement so that no two boys or no two girls can sit together.
okay.
And the sum
So
that you had discussed
let's
about
say,
Indians and Australians, some 10 Indians, 5 Australians, and 5 Americans. So I'm getting confused. Just to give the idea solutions, I'm getting confused between the two sums.
okay. So let's say this is I will write it something. Okay, these are 10 Indians,
Yes.
5 Brazilians, and 5 Americans.
Yes.
Okay, this is one set of problem.
Yes.
Other set is I am having total of 4 girls and 4 boys.
Yes.
Okay.
Yes. 4 girls and 4 boys.
Okay, these are the two different
Actually,
problems.
the answer for
And
given in the solution is wrong or what?
where for which question?
This question, 4 girls and 4 boys.
No, I think we have discussed, right? It's correct only, right?
Yeah,
it's 2880, na?
No, it is something in 30,000 or something like that. It is given.
2880 is the answer.
In the solutions which are provided, actually no solution is provided. Only the answer is there.
Yeah. In this one only, sir. You can scroll up. Question number 6.
No, but the solutions that are provided to us, there the answer given is.
But solution is not provided.
Solution is not provided, and only answer is given, and that is also very big.
2880, right? This one.
2880.
No,
that's correct,
no,
right? We have discussed it, right?
What solution that is provided to me, there the answer given is very big in 30,000 something, and the solution is also not provided. I think that is some typo mistake.
You are saying you are not providing.
No, the solutions that are provided, the solution for this question is not present there, and only the answer is there, and that answer is something not which is that we had found today.
Maybe you have got some other question with some different number. 4 boys and 4 girls are there. Can you tell me your question?
I will just.
Can you tell me your question?
Yes. I'm opening.
Just check that question. Just check that question once.
And for that Indian Australian also, the answer given in the solution is something different. 10 factorial into 10 factorial, something like that. So that's why I'm confused a bit.
Actually, there are of question papers. So maybe you have got some the other set of question paper. There, these numbers are different. Just can you check your set of question paper and tell me the numbers?
Okay, sir.
Yeah.
Sir,
so you may continue. Once I find that, I will ask you.
Sir, just a quick check over here. In this 6th question, we will take both the arrangements and we will multiply the factorials, right? 4 factorial into 5 factorial, correct?
Yes.
Yes. Okay. Fine, sir. Fine.
Yeah. Sir, by the time, can you please the mock test 5th, the similar one, 2nd question.
Yes, sir. I got it. Can I tell? In a family,
Hello?
4 boys and 4 girls are there. In how many ways the sitting arrangement can be made such that no 2 girls should sit together, and the answer given is 37,440, and no solution.
So that is an error.
So that question is not that answer is not correct.
No.
Yeah, that answer is wrong.
Yes.
But I don't know. Same thing is there. It's showing on your portal, right?
Yeah. So, but we are not given solution.
Yes,
Solution.
and there the solution is not provided. For other questions, the solution is there, but for this particular question, the solution is not there, and the only answer is written. So actually,
So
that's
there
why
were
I was
many
confused.
questions. There were many questions like this where the answer and the solution is incorrect to what we have got. That is also creating a lot of confusion, to be honest.
But actually,
I don't
we
understand.
don't have a solution PDF only, sir.
Yeah, so if you don't have a solution PDF, then I don't understand how you're getting the wrong answers. That's what I'm saying.
Yeah.
See, what I'm seeing here, that same thing is showing on your portal, right?
Yes, sir. Same
So
thing. We do not have solutions.
So
I'm from
no, it's okay.
second
Detailed
semester.
solution, I'm not. Okay, there. So when in second semester, which paper? Which paper you're saying?
This
Here?
is mock solution.
So for
But
those
this is for
who
quiz
have
2, I think. Quiz 2 it is written in our. Yes.
quiz 2 there, right? So January 24, 2021, like that, this showing there. QP 2 or
Quiz
1?
2, question number 6. Quiz 2, question number 6. So that's why I was confused. I was trying a lot, but I was not getting answer.
Can you tell me this? Is it QP2 or QP1?
Oh, yes, sir. It is no, it is only written mock solution quiz 2 period. That's all.
Is it?
Modified 10th July.
Okay, one minute. There is no set 1, set 2 written there.
No,
Nothing is there.
this is the mock solution which is provided in the recently.
Actually, I'm not aware of whatever I'm seeing here. It is back end, which can be seen as the front end to you guys. Like that, I know that thing. This is not the case.
So this is from the previous term, right? This is from the previous term.
Yes, this question was there in.
But we have not got the previous term question papers. Only the end term paper has been provided. What you are looking at is at January 24.
No, but the end term solution and mock test for end term is given. Below that, mock solutions are given, and when you open that mock solutions, we have the solutions of 3. That is the end term mock and quiz 1 and quiz 2. And there in the quiz 2, this question is present. For the answer is given as 37,000 something.
Okay, maybe some mistake.
Okay, but that answer.
Hello, sir, am I audible?
The question?
Okay, sir.
Yeah, okay. There is some confusion, I guess, somewhere. Okay, can you tell me the questions you are saying?
The question is same, sir. 4 girls and 4.
4 girls and 4 boys.
Yes. The question is.
Is it?
Yes, sir. Question is same.
Okay, maybe some mistake has happened there. I really don't know what. Because here, if you can see the April qualifier paper, it is given correctly, right here.
So shall I read the question once again?
Sir.
No, it's okay, Zach.
In a family, 4 boys and 4 girls are there. In how many ways the seating arrangement can be made such that no 2 girls should sit together? So whatever we solved in the beginning is correct, no? Because I have solved in the same way.
Yeah, it is 2/0, correct.
So the answer is
5 factorial. Yeah.
It's 4 factorial into 5 factorial.
Yes,
it is
4 factorial into 5.
2880.
Yeah.
And for that, some Indians and Americans and Australians, it is 10 factorial into 11C5 into 6C5, something like that.
11C5 into again then 5 factorial. So it's basically
okay,
11P5.
Okay, 11P5.
Into
6.
Then into 6P5. Okay. So the answer should be 11p5 into 6p5 into 10 factor.
But
So it's
for this also
huge
the
number
answer
actually.
given is something 10 factorial into something like that, into 10 factorial something. So this
Okay,
answer,
tell me. Can you tell me that no?
some
What is
other
the answer?
option is given. I will have to find.
10 factorial into 10 factorial into 2.
Yes, 10 factorial into 10 factorial.
Oh, is it given there like this? Huh?
Yes.
10 factorial,
Yes,
10
sir.
factorial into 2. Okay. Okay. No, but this is the correct answer. What written here, right? So maybe there's some mistake is there. I don't know. Some different. I think some different papers, some different answers are written there. I don't know. So it is given in the detailed solution. You are saying, right?
So whatever you have told is correct. No, this answer.
Yeah.
Yesterday
This
also
is
you discussed the
This is
same
correct.
question, and I understood that way. Okay.
I was not there, but yeah, okay. So some other person was there, but yeah, this is the way.
Sir, can you explain
Now
from mock
whatever I
test
showed,
4?
right?
Second question.
Okay.
Mock test 4.
Actually, there are two types of people here. One is from April qualifier, and one are from this second term.
Yeah, the second question. Yeah.
So yes, so some of them only have just given the qualifier paper now. They are directly giving the final quiz. Some of you might have given the here, right? The create what will be the 121st word, right?
Yes.
Okay, so I will just write, I'm not asking you how to solve. Okay, I'll just write it down. So just create. These are the 5 words. Okay, this is the word, and in that word 5 letters are there, correct? 1, 2, 3, 4, 5, 6 letters are there, right? Is it right?
Yes.
So if you are going to arrange some words in a dictionary, so it will start from A, right?
Yeah.
A, B, C, D, like that. So say here, if it starts from A, so how many places are there to fill? 5.
Yes.
Right. So in that 5, how will you start doing that? How you will start filling the words? So after A, it will be E, right? After A, it will be E. Then again you can have, so you have the 2 E's, so you can have E again, right?
But how come E? Why wouldn't it be that be C? Because alphabetically, right?
Oh, sorry, C.
Yeah.
A, then C, then E, then A, B, C, then again the alphabet, that whatever dictionary order it follows, right? So let's say P, O, P, Q, R, T, yeah. So like that. So like that you have to solve that, right? So if I'm having A first, I'm having 1, 2, 3, 4, 5 places remaining, and we have to fill the 5 letters remaining from A in these places, 5 places. So how can you fill that 5 letters? How many types of combinations are there?
No.
Permutations
What
are there?
will be the 121st word?
Yeah, that's okay.
121st word.
Yeah, we'll come to that later. 121st.
Yeah.
Now tell me, if I want
5
to fill
factorial
these
upon 2
5
factorial.
places, it should be 5
5
factorial
upon 2 factorial.
Why this 2 factorial? You understand, right? Because E is
Because
coming
of
2
this
times.
E repeat. Yeah.
So the answer is 5 factorial divided by 2 factorial. So it's 60, right?
Yes,
Correct.
60. Yes.
Yeah.
Now what will be my 61st word? So 61st word will start from C.
C.
Correct. Getting in this way we are arranging the dictionaries, right? First of all, A will come, then whatever the combinations required with A, we have written down there. Those are total 60 possible words where A will start first. Is that okay?
Yeah.
Huh? Who asked me? Dharanga, I think.
C. Yes.
Yeah. Then it will start with C. Then again, how I am having 5 more places here.
Yeah.
So these 5 places, how can I fill? Again, 5 factorial divided by 2 factorial, right?
Okay.
So this will be total 60 possible permutations.
Okay. Yeah.
Now total how many words?
Sorry.
120. How many total words?
121.
No, until now how many are there? 120, right?
Yeah, 120. Now we have to
We are
find
arranging this
121.
dictionary. So until now 121st. So your 121st word will start from E, right?
Yeah. Okay.
Then
From
I'll write E.
EAPERT.
Correct.
No, it should be EA, correct, sir?
EAC.
So
Oh, sorry.
EA.
Yeah.
Yeah.
Oh, sorry.
Yeah.
Yeah. Okay. Yeah,
Got
sorry.
it.
I was okay. E. So that will be the answer. That will be 121st. So whenever you are finding out some kind of these kind of words, first of all, you have to start with some letter, which is coming first. Then you have to find the different possible permutations of that word. Then you have to calculate how many words are there. Then you can go
Okay.
to the next word like that.
Okay.
Okay.
Thank you.
Yeah.
So can you give some last minute tips for tomorrow's examination paper specifically?
So paper will be like this only. So I think you have gone through a lot of questions, right? So yeah, okay, I can tell you that one thing. Maybe we have posted the announcement regarding the syllabus, right?
Weightage, right,
It is
right.
it's like this, right? So
Yes.
15 or maybe 15 to 20%, then 35 to 50. So I think this is provided only for you guys to know that the major portion is from 5 to 12. So you can just focus from 5 to 12, and you can if you can't able to do the study right properly, then for entire subject, then you can first of all focus on 5 to 12 and then you focus on 1 to 4 if you have time. The other thing is you'll be having 1.5 hour paper, right? So 130 minutes paper. So we are mostly asking from 15 to 20 questions. So this time it will be easy for you guys. So this kind of questions, maybe you'll get good amount of time to solve this. So just think about properly for each question.
So
Right.
20 questions.
Solving the yeah, in between 15 to 20. So yeah, that can be 16, 17, 18. That will be you will get into tomorrow. Yeah, but yeah, just in that range, 15 to 20. Maximum is 20, not more than 20. Okay. The other thing is you should go each and every question slowly, right. First of all, read that question carefully, then try to write it down in your words, then you have to solve it. You will be getting sufficient time to solve this paper compared to the quizzes. So in quizzes, and one more thing is a lot of people do mistakes in, if you get stuck in some other question, right, just leave that question and you go to the other question. So sometimes you will be getting first question itself very tough, and it will consume a lot of time and it will take down your confidence. So just go to second or third. Yeah, apart from that, what I can say to you. So
Sir,
yeah, okay.
for us who are 50 plus, we are getting some extra time to solve. 20 minutes extra per hour.
Why?
For those who are 50 plus, they are getting extra time. 20 minutes per hour will be allotted now. I received a mail in the afternoon.
Okay. Then it's fine, right? So you'll be getting a lot of time.
Yes, sir.
So yeah. So and one more thing is to get past, right? 50% is enough, right, for individual subject. So if you can just focus on this last 9 to 12, if you can do it properly, right?
Yes.
Then and from if you know this permutation combination probability concepts well, I think you can easily score more than 60 to 70%. So first of all, just try to that try to overcome that barrier of 50% first. Focus on that, and
no, sir,
if
age
it's in
50 plus, those who are.
yeah, no, I understand. I'm saying it generally.
Yes.
No, I'm saying it generally for everyone. because sometimes I saw that a lot of people solve all the questions. Okay, all the 16, 20 questions they will solve, and what they do is they do like more than 12, 13 questions wrong, so that their scores are like very less in the examinations. So I think it is because they are not properly doing the management of which questions they need to solve. They are trying every question, so don't try every question. Just try those questions where um you are confident about, and you think you are able to solve that. So if you do that, I think you are able to pass this paper. Apart from it, it is nothing, I think. So this permutation, combination, and probability, these three topics are somewhat difficult, right, in our
Yes,
entire
sir.
course.
Yes, sir.
Yeah,
Right.
otherwise other topics are not much difficult. The continuous random variables also, it's not that deep, so that is also not difficult. And first 4 weeks also, I think you have done lot of times. So if you don't study also, I think it's kind of, you know that, right? If you don't study also, I think you can solve those questions. Apart from some formulas like point biserial coefficient and covariance formulas like that. Apart from I'm not seeing any trouble there, I guess.
Sir,
So
can you briefly tell us the inference drawn from that graph of biserial coefficient? How to draw that inference, or relative
graph.
density is given, and then how to draw the inference? Some inference is to be drawn, whether it is favorable or not. Covariance are is given. So they ask us to draw some inference. So can you briefly?
Sir, I also have one more question, if it is okay. I mean, I know it is over time, but if it is possible for you to take.
Yeah, you can. You can. I thought you were saying. Okay, you can ask me the question. Yeah, it's not.
So it is activity 10.4, question number 5.
Okay, 10.4 question 5. Yeah. Okay, I'll come to the other, that biserial, right? I will come to that. So that point biserial correlation coefficient, what you are saying is how to draw the inference. You are saying. Huh? I
Yes.
don't understand the question
Some
properly.
sometimes they give some data, some tabulation is given, and they ask us to draw some inference from that. I think in the quiz, first qualifier quiz or somewhere, we had such question.
Can you just tell me the exact question so that I can
I will have to
do this?
search. Okay, let it be. I will
Okay,
try to search.
search. Until that, I will
Yes, yes.
solve this problem.
Okay,
Yeah.
no problem.
So, which question?
Sir,
10.4
activity
question number
10.4, question number 5.
last one. Huh?
Yes, sir.
Okay. Okay. So yeah. So this is actually you can solve in multiple ways, I say, but you can see from this probability distribution itself, it is a uniform distribution, right?
Yes.
So just go for variance. What is the you know the variance, right?
NP
B
1
minus
minus
a
P.
to the whole square by 12.
Oh, okay.
Oh,
Okay,
sorry. Oh, okay. No. Sorry. I did mistake. Okay, that is continuous distribution. B minus a. No. Here it's
NPQ.
this is a discrete one, right? NPQ. Yeah. So what's the problem here then? I think it's
Sir, not able to understand. I was not able to understand. Would NP into 1 minus P work over here? Kya?
yeah. So n into this is discrete, na? This is discrete uniform, right?
Hmm.
So total n, what is n here? N is 20. What
20
is p here is 1
into
by
1
20,
by 20.
and 1 minus 1 by 20. It is 20 into 1 by 20 into 19 by 20, right? That should be value, right?
Just checking, sir.
This is
0.95. No, sir. 33.25. 19 divided by 20 is 0.95.
it is less than 1, but I am not 30. What is the variance of a random variable whose probability distribution is like this?
Sir, ऐसे ही हो रहे हैं कई questions में. I mean, we get stuck with whatever is the answer displayed.
1 meter. Maybe this 1 2.
Sir, how?
20.
Why have you considered P to be 120? So we
What?
why have you considered P to be 120, 1 by 20?
Because it's given here, right? Everywhere it is same, right? 1 by 20, 1 by 20. Oh, sorry. Okay. This is not a formula for variance of discrete uniform. It is a formula for Bernoulli. No, this is
So
wrong.
we take that B minus A whole square by divided by 12.
No. That formula is
that
for.
is for
Okay, so do we take E of x square minus E of x whole square here?
You can do you can do that way. So expectation of x square in minus expectation of x to the whole square here.
Okay.
Here
That
you
is how
can
it
do
will come.
So yes, so it will be again you will get one table here.
Sir, n
So
square minus 1 upon 12 for uniform distribution. 1 by 20, 1 by 20. 1 by
but I
20,
think
1 by
for
20, the
uniform
probability is same. So n square minus 1 upon 12.
Sir,
Uniform is continuous, right?
Sir, calculating this
uniform, there are
particular
two
thing.
One is discrete uniform and one is continuous uniform.
Yes.
But right now I'm forgetting the formula for actually there is formula for discrete also for variance, and for continuous it's b minus a square by 12, right?
Yes.
And for continuous it's 1 upon b minus a for that expectation, right?
Yes.
But
n square minus 1 upon 12, this formula is there. It is called.
So there is a formula for discrete also, but I'm forgetting that formula. I'm not
So we have been only taught. So we have been only taught this formula: expectation of x square minus mu square. So how will it be possible? I mean, how for 20 random variables and then doing its square? Would it not be so lengthy in calculation? I mean, you have to multiply 2, 3, 4 by everything by 20 and then do its square and then again multiply by 1 by 20.
Is this problem is like
For
a
example,
die?
20 into 20 into 1 by 20, then 19 into 19 into 120.
No, actually, there is a formula for it. So which is n into n plus 1. Sorry, actually for the calculation of square, there is a formula which is n into n plus 1 into 2n plus 1 divided by 6.
Correct. So that formula, but don't worry, it is not taught in the lecture, so don't worry about this. We can go with this itself.
That
I will tell you how you can solve it
to us in the revision.
No, it's okay. It's okay. So how that can come so sometimes it is, see, that formula, it is not that easy
Sir,
to
I
remember,
think that
right?
formula is also derived in the lecture by using summation of n square.
Correct, sir. Right. N
So
square
I will tell you.
sorry, a square plus b square plus ab. But that is again
if you can
for
give me just a time, then
sure,
I
sir,
can solve. So
sure, sir.
Sorry, because so this is the basic formula. If you don't remember any formulas, right, it's okay. So this is the basic formula: expectation of x square minus expectation of x to the whole square. This you
correct,
know, right?
Sir. Right.
Okay.
Right, sir.
Now how can we are calculating expectation of x square? We are just squaring this, right? And all the probabilities are same. So everywhere 1 by 20, and you can write this 1 square plus 2 square plus 3 square, right?
Yes,
it is same,
sir.
right? 1 square into 1 by 20 plus 2 square into, so this is same.
Yes,
So
yes.
until plus
20 whole
20 square it is same. So this is okay, and you have to subtract. So it is 1 by 20, then it's 1 plus 2 plus until 20.
And
So
it's
this is
whole
sum of
square.
first 10 natural numbers.
Answer, it's whole square, overall whole square.
And it is whole square. So this is sum of total
n plus 1 by 2
natural numbers.
n plus 1 by
So
2.
here correct. So here it is 20 into 19 by 2 into
Yes.
it's 1 by 20. So it's 19 by 2 to this whole square, right? This value you are getting. Okay, that is okay. Okay. and here it is sum of squares of first n natural numbers, right?
Sir, n plus 1 by 2 होएगा ना? n multiplied by n plus 1 by 2.
Yeah. No, n plus 1, right?
So it would be 21 by, yeah, fine.
Yeah. Okay, then here it's first sum of first n natural numbers. So can you just tell me what is the formula for that? Maybe it's this 1 by 20 is here. Okay, 1 minute, I need to search. Anybody knows the formula here? Not actually good at remembering the
n plus
formulas.
1 चाहिए
1
वहाँ
minute.
पे 2n plus 1 into n plus 1
n into n plus 1 to 2n plus 1 by 6.
plus, yes. Actually, for variance, the formula is n square minus 1 upon 12 is given in the lecture as well for discrete uniform variables.
Okay.
Variance is n square minus 1.
What is it? Oh, okay.
So it is n into n plus 1 into
So
2n
n plus 1 into 2n.
Yes, but
6.
for discrete
this
uniform
one, right?
variables, the variance, we are calculating the variance, no sir?
1 by 6. So 1 by 20. Here it's 20, 21, 22 by 6, right? Okay. So 21 into 22 by 6 minus 21 by 2 square. If you calculate this, I think you'll get the answer. For you guys, you are saying something. So it will be P into the sum of first n natural number squares, right? I will derive that formula now. So it's 1 plus 2 plus 3 plus dot dot dot. Sorry, 1 square plus 2 square plus 3 square plus dot 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 plus n square, right?
Yes.
Minus p into, and that to the whole square. So 1 plus 2 plus dot 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 plus n to the whole square. So we know that, okay, we can take, okay, p here common, then here it's n into n plus 1 into n plus 2 by 6, right? Somebody was saying about this formula, right? This is expectation of x square, right?
Yes, ex square is n plus 1 into 2n plus 1 upon 6.
So this is square here. So I think that big formula you have to remember. Or okay, let's see, we can go to this
So,
kind of
but if we don't remember these kind of formulas, for example, n plus 1 into n by 2 by 6.
Here, this one, right? So then there is no option. Just do this one.
Then
this one, fine. Like mostly people remember this formula. This formula, see, I also don't remember.
Yeah, exactly, sir. That is what I'm saying.
I'll be there in your, but in the quizzes and the papers, right? We just do. If you see the papers right now, we don't have this kind of questions where you need to remember the formula, right? So, but this is for practice assignments or somewhere in graded or somewhere in activities where you can do a calculation or you can search it from somewhere, right? So there we are. So just generally I also don't tend to remember this formula. So sum of first n natural squares, sum of cubes of first n numbers, right? There are a lot of formulas are there, but I am also not good at it. So but it's okay anyway. So this kind of some combination you get, but you can remember this kind of formulas: n into n plus 1 by 2, first sum of first n natural numbers. That is expected from you guys.
Sir, I think the formula that you have used, 1 square plus 2 square plus 3 square plus up to n square is n into n plus 1 into 2n plus 1 upon 6. Sir, please check it once.
2n plus 1, huh?
Yes, please check, sir. It is not n plus 1.
2n plus 1. Correct. Yes. Okay, it's okay. 2n plus 1. Correct.
So will the 22nd exam be similar to this? I mean, the weightage will be similar?
Session over.
I think there is some network problem. Cannot hear Mayur.
I think Sir lost his connection.
Yeah, right. Yeah, he's not there.
I think he has left.
Hello, hello. Am I audible? Hello. Hello.
Yeah, yeah.
Yeah, so guys, I actually contacted my user. I think there is some network issue. He will be there soon. So kindly wait, please.
Are you guys still in? Huh? Okay, so I was disconnected. Hello, am I audible?
Yes, sir, you're audible.
So okay, I was disconnected. I thought I did not connect because I thought it's done. So
Yeah, most of
do
the
you guys?
remaining guys are just to say hi to you and probably to plan to leave.
Yeah, yeah. So actually, okay. So you guys don't have any problems. Then shall we wind up then?
Yeah, I think it's good.
So okay, okay.
Right
So
then.
okay, you guys are okay. Best of luck for tomorrow's exam.
Thank you, sir, and good night for
Yeah,
you.
for everyone. Yeah, maybe those who joined earlier, I wanted to tell them, but in between the network was gone out. So sorry about that.
Yeah.
So yeah.
Thank you.
Okay, okay.
All right.
So
Bye.
then, okay, bye bye, and best of luck for tomorrow's
Thank
exam.
you.
Okay.
Yeah.
Okay. Bye.